Hello and welcome to this week's devlog for my procedurally generated voxel-based RPG game. This is a game where I attempt to distill the feeling of exploring those large fantasy worlds that you tend to find on a console or PC into something that fits quite well onto a mobile device and can also be played on a PC. And this week, technically 2 weeks, I focused on getting bits of the world to appear as the player moves around the world, so it kind of gives that feeling that they've actually discovered something. To help you understand, imagine that this is the flat earth and that this is the bit of the world that the government doesn't want you to see. Anyway, now that I've explained that with a perfectly rational thought process, here's how I implemented it in the game. So I wanted to divide the world into different sections so I could do things like animate different bits of it in, or give them different materials depending on how discovered they actually are. The problem was that the world right now is just a single mesh, and also I haven't actually implemented the concept of regions into the game yet, so I need to get on with that. So the way I did this was that each voxel keeps track of which region it's a part of, so I just use 8 bits to that, and then as the player moves around you can just check each voxel with the player's sort of circle radius around it. And using that you can just keep track of which regions have been discovered and which haven't. So I didn't really want to be too smart about how I actually did the region specification early on because I just needed to get the technical in place. So what I did was I just went through and added, like with a banding system, just a few different regions, and you get this kind of weird striped effect of which bits of the world have been discovered or not. So with that, in order to get the different meshes that I needed, I did a really dumb approach and just looped through the regions and then fed them off individually to the voxelizer. And fortunately they all still fit together. So without knowing anything you can see that the map is basically identical, but if I was to go through with the debugger tools and look through to see what region the various bits of the land are a part of, you can see that it's kind of drawing it with this banding effect. And as a result of that, you can see that as the player moves around the world, I was able to make it so different nodes became visible or not. So that was fun. So you can see that the world kind of unveils itself as the player moves around it. And from there I wanted to make sure that I sort of made it look a bit more interesting, so I built a system of materials that could make it so you can actually see which bits of the world are left to be discovered. However, one problem with this was that you could still see objects like trees. So part of the system was that I wanted to hide where the gateway was because the gateway is used to end the exploration. So I built a system that just kept track of the individual placed items in the different regions and was able to hide them accordingly. I had to do this thing with seed nodes to hide them. I mean, it worked perfectly well. So that was where I got to by the end of that week. The thing was that what I ended up with, it worked from a technical perspective, but it also didn't really look that realistic as everything was just a rectangle. There's no real sort of sense of discovery if you're just hunting down rectangles. So what I thought was to try and sell the full effect, I would instead implement the flood fill algorithm, but I would need extra time to do that. So I would bun the video off for the previous week and then just cram it all into one big video that you're watching right now. I also went to Stonehenge last Wednesday. I kind of assumed that I would have time to make the video, but I guess not. I took some awful tourist photos. They weren't really that good. Anyway, we drove back and I had a massive headache. I just retreated into bed, but the thing I decided was that the coming week, there would be regions. So here's how I did that. The first step was to cover the map with region seeds. So the point of the seeds is that it just tells you where the region actually begins. I determined these seeds by finding a random landmass of a certain size and then finding a random point within that landmass, and then set about finding an algorithm that I felt could do the job appropriately. So I found what I thought looked like an interesting algorithm on YouTube, which this guy had called the lazy flood fill algorithm. It's essentially a flood fill, but it kind of diminishes in likelihood of it actually being able to continue as it gets further out. So you end up with these sort of blobs, and that was sort of what I was looking for. So I thought I'd be smart and update my already existing flood fill algorithm to this lazy form, and the problem was that that algorithm was implemented in a recursive way. Basically, all you need to know is that the first request to the flood fill system is the one that gets processed first. So you end up with something that has a massive priority in one direction over every other direction. I mean, I think it looks cool, but it's obviously not what I want. So I just completely rewrote the entire thing based on the pseudocode that the guy provided in his video. After making a bunch of bad life decisions, I eventually got it working, and you can see the nice little globules that it ends up making. And they look beautiful. But the biggest problem I had here was getting the regions to reliably cover the world. Now, unfortunately, you have different seeds and they expand outwards, but that's not to say that every single bit of land voxel ends up properly designated with a region. everything is part of region 0 originally, unless they get hit by the algorithm, which then sets them as whatever the appropriate flood fill ID is. So the problem with that is that you end up mostly in a situation where the vast majority of voxels end up in the default group. This led to situations where when you were playing it in the game, you'd move around the world and then suddenly all the world would become visible to you at once. I kind of wanted to have it looking a bit like the player would arrive and they'd initially have a bit of the land that was visible to them, but it was like in the middle, and then outwards everything else would be hidden. So in order to do that, I had to tweak the numbers quite a bit. So one of the things I tried was that I deprioritized sections of water. So if the algorithm ever hit a bit of water, it would sort of be weighted less and would also cause less of a decay in the chance of where you were likely to continue the flood fill on. And then it would hopefully kind of expand outwards and fill out all these various bits of land until the land was mostly covered. That was the idea. Another problem I was having was that you ended up with these seed locations which were sort of like dead on arrival, because essentially what would happen was they got placed in a bit that had already had the flood fill expand, and then the flood fill would look at its various bits of data and say, this bit of land has already been expanded on completely, so I guess none of the tiles next to it are viable, so I'll just skip it entirely. So that was kind of an interesting one. What I essentially had to do was defer the seed creation, so you'd have a loop and you'd say give me like 16 regions, and then it would generate you a seed, flood fill, generate you a seed, flood fill. It used to be that it would generate 16 seeds and then do the flood fills necessary, so that was actually not too bad of a fix. So with that, the gameplay worked. I mean, some seeds worked better than others, so you can see this one kind of gets the effect I want, but then you can see these other ones that kind of don't, and the regions are splattered around like they've gone paintballing or something like that. So like the world generation has to be generally quite reliable. I think it can give bad worlds sometimes, it's probably inevitable that it will, but I think if by and large most of the worlds are interesting, then that will be fine. But one of the things I did want to experiment with was trying to animate the arrival of that bit of land. I really just did a bit of an easier approach, which is just to get it to kind of rise out from the sea. But obviously in future I'm going to have particle effects, GUI effects, all sorts of things. Like, I think discovering new regions is going to be a big part of the game, and I'm also going to specify different regions based on like their rarity. So I'll have some regions that are really rare to, you know, it's kind of that slot machine vibe of, oh, what are you going to get when you go out exploring, you know? Right now it's just, oh, it's another bit of green field. Who cares? So I would just like to take a quick moment to tell you all about the things that are wrong with it. The main thing is the voxelizer. It's completely baffling how long it takes to run now. You're literally looking at 10-15 seconds. I did it in an extremely inefficient way, so essentially I just go through each region and then pack all its relevant data into the array and then send that off to the voxelizer. So yeah, that's just massively inefficient. I mean, this isn't even like that programming archetype of you make it work, you make it pretty, you make it fast. This is like, okay, I've made it work, but it's so slow that I basically can't test anything else without fixing this in the next week. So the other problem is that the generated algorithm has a bit of a quirk where it tends to stick these little like nodules into the map. Essentially what's happened is that the algorithm has just missed a voxel and it hasn't got a region appropriately, so as a result it just ends up on region 0, which means it's sort of visible most of the time. The other thing is that I would actually be quite interested to try a few different algorithms for specifying the regions. The main reason is that I think I could probably have a bit of more optimized algorithm, because if I have to do a flood fill to check like everything is perfectly concave or anything like that, then from my perspective I think the priority needs to be efficiency while also giving the best sort of map you can. So I'm definitely keen to experiment with things, because it's a case of like, if this is worth the time cost or the CPU cost in order to generate it, but the gameplay is way better as a result of that, then actually I'm fine with that. But for right now, yeah, I think I just need to try different things, but I'm very much reaching the point where I need to start optimizing this thing. The thing is that as the maps start to get bigger, it gets exponentially slower, and I'm beginning to notice that. Like, if you set the map to be 800 by 800, you'll literally be spending 30 seconds sat waiting for it to finish generating the map. So that's just not the best. It's not a vibe. But from my profiling that I've done, the biggest bottleneck by far is the voxelizer, which I kind of expected, so that needs to be optimized. The problem is that it's all implemented in scripts and not C++, so there are some possibilities to get maybe closer to the metal on that one, but they're all not the best, so I think we'll have to see how that goes. If I can optimize it in scripts enough to the point where I can continue developing it, then I don't think I care so much. I do want to have a focus a bit more on the actual animated stuff in this game. I think even that animation of the stuff coming out of the water greatly enhances the feel of playing that thing. So I think what I'm going to have to do is just improve it later on. So, thank you for watching this video, friends. I'm just going to eat this bowl of cereal as an outro. Unfortunately, I don't actually have any milk. Oh, well, that was fun. That was drier than my sense of humour.